Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 1 from the October-November 2023 paper 4 variant 2 from the Cambridge 0580 IGCSE series. And one of the students has asked you to answer this question. We have a question about transformations. We have this triangle T. It says translate triangle T by the vector -7, 1. Label the image K. Okay, so we can choose a point, for example. Let's choose this point, which is the right angle kind of part of the triangle, and we've got to translate it by the vector -7, 1. So translation by the vector -7, 1. Okay, so -7, 1 means we got to move 7 spaces to the left and 1 space upwards. The top number in the vector represents the horizontal motion and the bottom number the vertical motion. So let's take this point and go 7 spaces to the left. So we're starting at 6, we're going to end up at -1. Then 1 space up. So this point is going to end up over there. And for the rest of it, because everything is translated by the same amount, we can just say, okay, the point 2 squares above it will be the top of the triangle, and the point 4 squares to the right of it, to the left of it, sorry, would be the point of the triangle over here. So that's from 6 to 2. So this would be from -1 to -5, 4 squares. Okay, 1, 2, 3, 4, 1, 2, 3, 4. So we join those together, and we have our transformed shape. This is the triangle, and we're asked to label this triangle as K. Okay, so this is K. All right, so we have labeled the triangle K. This is the original, translated by -7 and 1. Now, 2 says describe fully the single transformation that maps K onto T. So how do we go back from K to T? Well, we've got to do the opposite. We've got to go 7 to the right and 1 down. So it'll be the same as this vector, the opposite signs. This is from K to T. This is from T to K. Okay, so we can just say it's a translation of 7, -1. Okay, so we can say translation of 7, -1. Simple as that. Then it says reflect triangle T in the line y equals 4. So y equals 4 is a horizontal line. Okay, so is it y equals 4? Yes, it is. A horizontal line which passes through y on the y-axis, through 4 on the y-axis, sorry. So this is a line y equals 4. This is a line y equals 4, a horizontal line, everywhere on that line y equals 4. We got to reflect this triangle in this line. So basically every point will be on the opposite side of the line, the same distance as it is on this. So for example, this point will stay as is. It's on the mirror line. This point will be 2 squares above the line because it's reflected always 90 degrees. Okay, so it's always perpendicular to the line. This point will be 2 squares above as well, and these will be joined together as follows. So you're just going to join these together to make your triangle. Okay, and that's your reflection in the line, y equals 4. Okay, so I'm going to just draw this line a bit dotted so it doesn't interfere. So I'll draw it like a dotted line like this. Okay, that's the mirror line. Okay, that's better. Okay, now, and we have to label this triangle what? No, they didn't tell us to label it. Okay, so reflect T in the line y equals 4. So that's part B. So I'll just write here, just to make it clear, that this is the answer to part B. Okay, so there's the answer to part B. Then it says rotate triangle T through 90 degrees clockwise about the origin. Now to do that, okay, a nice easy way of dealing with it would be using tracing paper, okay, which I have prepared. Okay, so I have some tracing paper, which let's say we place it over, okay, over the the shape, and we basically trace the image, or we trace T on top of the tracing paper. Okay, so we've traced it on top of the tracing paper, and then we put the pencil on the center of rotation. okay, which is the origin, okay, and then we rotate clockwise. Now, clockwise means going in this direction through 90 degrees. So basically, we can say when this line is vertical, we've gone through 90 degrees, okay, or where this handle is now going to be over there, we've gone through 90 degrees. So let's rotate through 90 degrees and see what we get about the origin. Okay, this is going to be rotating about the origin. We end up with something over here. It looks like this. Okay, so we rotated this 90 degrees about the origin. So we end up with our shape over here. So we lift up the tracing paper and we draw the triangle in that place. Okay, so we end up with our translated image. So a rotated image. And it tells it to tell us to label it? No, it doesn't. That's it. That is rotation about the origin 90 degrees clockwise. Okay, so I'm going to label that actually as part C. So that's part C. And then part D is telling us to enlarge triangle T by the scale factor -1/2, center 0, 0, label the image P. Okay, now, so we got this, the T, yes? T, good. So we've got here our center of rotation, the center of enlargement, which is going to be the origin. Okay, we want to take this triangle and we're going to enlarge it by a scale factor. We have enlargement. Scale factor equals -1/2. So what I'm going to do is I'm going to take each of these points. I'm going to call this point 1 and point 2 and point 3. And I'm going to find the vector that takes me from the center of enlargement to that point. Okay. In fact, I'm going to call it, let me call them by letters. Let me call this point A, point B, and point C. Okay, this is, I'm going to call it O, origin. So I know to get from O to A, I have to use a vector 2, 2. So from O to A dash, which is the image of A under this scale factor enlargement, it's going to be, I have to multiply this vector by -1/2. So I end up with -1, -1 as my vector. So from the center, always start from the center, I've got to go 1 to the left and 1 down. So the image of A will be over here. That's the image of A. All right. I'll do the same thing for B. To get from O to B, I've got to go 6, 2. So O to B is the vector 6, 2. So O to B dash is going to be -1/2 multiplied by 6, 2, which is -3 and -1. So from there, I've got to go 3 to the left and 1 down. So this is going to be my image of the point which I've called B. And then I can say from O to C, I've got to go 6 to the right and I've got to go 4 up. 6, 4. So O to C dash is going to be therefore -1/2 times 6, 4, which is going to be -3 and -2. So from the center of enlargement, I go 3 to the left and I go 2 down. So I end up with a triangle which is kind of upside down compared to the original and smaller. Okay, by a factor of 1/2. Each length is 1/2 the length as before. So this was 4 units, this is 2 units. That was 2 units, that's 1 unit, and so on. This was 2 diagonal squares across, this is 4 diagonal squares across. It's been halved and it's also upside down. So that's going to be my image. I put these labels A, B, C here myself. You don't have to put them. I did it just for my own information. So label the image P. So I'm going to put this as P. And then it says, describe fully the single transformation that maps P back onto T. So basically, it's going to be an enlargement, but this time it's getting bigger. But it's also upside down. So we can think about it as, if you want to find the center of enlargement, it's going to be the same center. If we actually try to draw the center of enlargement, find it by drawing, we don't have to, because we know if enlargement going this way is the same, going to have the same center of enlargement going the other way. But it's just the scale factor will be opposite. It will be like a reciprocal of it. So this is, as you see, it will just confirm to us that that's a center of enlargement. Okay, if you join a point to its image, okay, they meet at the center of the enlargement. So a point to its image, a point to its image, they will always meet at the center of enlargement. So the center of enlargement is 0, 0. So we can say it's an enlargement. So to describe fully, we have to mention first that it's an enlargement. Okay, and we have to mention the center is the origin, 0, 0. And then we got to mention the scale factor. Okay, so if we think about the scale factor, we can see, for example, it's always going to be, this is now the image, it's going to be the image over the object. So A to B is from 2 to 6, that's 4 units. And A to B here is 2 units, but in the opposite direction. So it's going to be 4 over negative 2, which is negative 2. So the scale factor is going to be negative 2. Right, we didn't have to actually calculate that. We should be able to deduce that. If the scale factor of enlargement one way is negative a half, the other way is going to be negative 2. Okay, it's going to be like the opposite. All right, but the same sign because it's going to be inverted. So there we have the answer to this question. The question that they was confused about, I think, was part D part 2. But I just did the whole question anyway for completeness sake. So I hope that was clear. Other questions from this paper can be found in the playlist that will be appearing over here at the end of the video. Other questions from the topic of transformations, IGCSE, can be found in the playlist over here. You can subscribe to the channel by clicking on this link, and the video here will tell you how to use my channel to find things that you're looking for. Thank you for watching, and see you soon.